Hello students, welcome to the third lecture on the lecture series in direct and inverse proportions. Okay, so previously we have covered all the theory and exercise and types of problems. So what we will be doing in this lecture is we will be covering more exercise problems. Okay, so let's start this part and do some exercise problems. So problem 1. So if 4 pens cost 20 rupees, okay, so you bought 4 pens, they cost 20 rupees. Then how much would 6 pens cost? Okay, so you have 4 pens, it costs you 20 rupees. Okay, then how much will it cost for 1 pen? So for 1 pen, it will cost you 20 by 4, right? That is equal to 5 rupees. Okay, so now what you have is you have 6 pens. So how much will it cost? So 5 into 6 is equal to 30 rupees. Okay, we can also do it in ratio type method, that is 20 by 4 is equal to what? X by 6, right? So this implies that x is equal to 20 into 6 by 4. So this is 5, so this will be 30. So 30 is the correct answer here. Okay, so setting up the proportion based on the direct proportion relationship, that is the number of increase in number of pens, so number of pens is directly proportional to number cost. Okay, as number of pens increase, amount of cost increases. As number of pen decreases, amount of cost decreases. Okay, so these are directly proportional. If one would be going up, that is number of pen would be going up and cost would be going down, then we would have said they are inversely proportional. Okay, but in this case they are not, so let's remove this thing. Okay, so substituting the given values and solving for the unknown, that is 20 by 4 is equal to x by 6. So what it will be is x is equal to 30 is equal to 5 into 6. Okay, so x is the cost of 6 pens, that is actually 30 in this case. So 6 pens would be costing you 30 rupees. Okay, so let's see problem number 2. Okay, so you have 5 workers. Okay, so you have 5 workers and they complete a job in 15 days. Okay, and a job. Okay, so only one job or task. Okay, that is what they complete in 15 days. So work rate of those 5 workers is equal to what? 1 by 15, right? Task per day, right? So in 15 days, how much they will complete? They will complete the whole job, because 15 into 1 by 15 is equal to 1. So how many days would it take for 8 workers to complete the same work? Okay, so what we have right now is we have 8 workers. Okay, so if 5 workers do this much amount of task per day, this implies that one worker work rate will be is equal to combined work rate, that is combined work rate by number of workers, that is 5. So this will be 1 by 15 by 5 is equal to 1 by 75. So one workers actually complete 1 by 75 of that task per day. Okay, so there are 8 workers working together. So this is by method 1. Okay, we'll also solve it by work time method. Okay, so this is method 1, that is a traditional method. Okay, so let's go forward. So then 8 workers would complete what? 8 into 1 by 75, that is equal to 8 by 75 tasks per day, right? This much amount of task they will complete per day. So how much time they will take? So they will take 75 reciprocal of this one work rate. Okay, so time needed is equal to 1 by 8 by 75. That is equal to 75 by 8. Okay, so this much amount of time they will take. Okay, let's solve the same using the what? Work time formula. So the work time formula tells us that 5 into 15 is actually equal to 8 into 1. 8 into x into 1. Okay, they are solving the same job. Okay, same task, and the number of workers is equal to 5 and the amount of time they need is 15. The number of workers is given here, the amount of time is not available here. So W1, here W2. Okay, so this is W2 and this is T1, this is T2, and this is M1, that is manpower 1, manpower 2. Okay, so this implies that what 15 into 5 by 8 is equal to x. So this implies that x is equal to 75 by 8. So as you can observe here, these two answers are actually ditto same. Okay, so this work time formula method takes only a fraction of minute, and the traditional way method takes you how much time? Like 2 to 3 minutes. Okay, so it is actually easy to solve it by this method, but actually if there is some trick involved in the question, it is better to go for the traditional way, because in that way it will take you 2 to 3 minutes. Okay, that is okay, but you will get the correct answer, okay, using correct logic. Okay, so let's go forward to the step-by-step solution. So setting up the proportion based on the inverse proportion relationship. So number of days is equal to into number of workers is equal to constant. Okay, that is what here method 2 is applied. That is work time relation is done here. So substituting the given values to solve the unknown. So 5 into 15 is equal to 8 into x. Okay, so x will be what? 9.3, that is equal to actually 75 by 8. This is what 9.3 is equal to. So problem number 3. So a car travels a distance of 360 km in 5 hours. Okay, so how much distance does the car travel? It travels 360 km. Okay, in how many time? In 5 hours. How much time? 5 hours. Okay, so how long will it take to travel a distance of 540 km at the same speed? Okay, so the car goes with the same speed. So speed of the car, 360 by 5, right? So this is equal to nothing but 72. Okay, so how much time will it take? So speed is equal to what? Distance by time. We have the speed, that is 72, and we have the distance, that is 540. We don't know the time, right? That is what we want to calculate here. So this implies that time is equal to 540 by 72. That is equal to what? So 72, it will be 7.5 hours. Okay, so this is nothing but 7.5 hours. It will take actually 7.5 hours. Okay, so let's see the step-by-step solution. So setting up the proportion based on the direct proportion relationship. So distance by time is equal to distance by time, right? So substitute the given values to solve the unknown. So 360 by 5 is equal to 540 by x. So x is the time to travel 540 km at the same speed. So it will take actually 7.5 hours to travel a distance of 540 km at a speed of 72 km per hour. Okay, so let's see problem number 4. Okay, so if it takes 6 workers to build a wall in 8 days, okay, so you have 6 workers here and they take 8 days to build a wall. So how much will it take for 12 hours to build the same wall? So by method 1, what we can do is we can use the work time formula, that is 6 into 8 is equal to x into 12, right? So number of worker is equal to, in the first case, W1 is this and W2 is this. T1 is this, T2 is unknown, right? This implies that x is equal to 6 into 8 by 12. So this will be 1, 2, so 4, so 4. Okay, it will be 4. So it will take only 4 days to build the same wall. So setting up the inverse proportion equation, so worker into day is equal to constant. So use the information from the first scenario to get the constant. So 6 into 8 is equal to 48. So use the constant to find the number of days with the workers. That is 12 days is equal to 48 days. Okay. So 48 by 12 is equal to 4 days. So it will take 12 hours for 4 days to build the same wall. So let's see problem number 5. So if it takes 15 days for 8 workers to complete a project, how many workers are needed to complete the project in 10 days? Okay, so let's use the work time formula again. So 15 days into 8 workers. So 15 into 8 is equal to constant. That is equal to what? 10 days into X number of workers. So here we have you assume as X number of workers are working on it. Okay, and they solve in 10 days. So what we have is, here we have a deadline and we can put any amount of workers. So how much worker do we need, or how many workers do we need? So this will be equal to what? X is equal to 15 into 8 by 10, right? So this is 2, this is 3. So 3 into 8 is equal to 24 by 2 is equal to 12, right? So 12 is the correct answer. We can also go forward with the traditional method. That is, if 8 workers completed the project in 1 by 15 days, then their work rate of 8 workers is equal to what? Combined work rate of 8 workers is 1 by 15. So WR1 is equal to what? 1 by 15 whole by 8 is equal to 1 by 15 into 8, right? So 15 into 8 is equal to 120. So how many workers do we need to finish it in 10 days? Okay, so it is being finished at so let X number of workers are there and they are working on it. So X by 120. Okay, in the numerator what we have is number of days or amount of task, that is 1, right? So this is what is covered in 10 days. Okay, so in order to cover this in 10 days, what we need is, we only need 12 workers. Okay, so X by 120 is equal to what? Such that this is equal to 10. So this implies that X is equal to 120 by 10 actually. So this implies that is equal to X is equal to 12. So X is equal to 12 is the final answer. So setting up the inverse proportion equation, so workers into days is equal to constant as given. Previously we have also seen this. So using the information from the first scenario to find the constant. So 8 into 15 is equal to 120, right? So using the constant and then new time to find the number of workers. So worker into 10 is equal to 120. So worker is equal to 12. So that is the amount of worker needed to complete the project in 10 days, right? So a car travels a distance of 360 km in 6 hours. How long will it take for the car to travel a distance of 540 km? So 360 by 6 is equal to 60 kmph, right? So in order to cover a distance of 540 kilometers, so what you will need is, you will need by 60, right? Is equal to time. So this will be 9 hours. Okay. So speed equal to distance by time, we all know from 12th class. So by this is equal to 60 kilometers. So using the constant speed and new distance to find the travel time. So it is 540 by 60 is equal to 9 hours, right? So it will take the car 9 hours to travel of a distance of 540 kilometers. So if 8 pence cost 240, how much do 4 pence cost? So let's use the worker time formula or work time equation. Here we can see that it can be also called as product cost relation. So 8 pen cost 240. So 1 pen 30. This implies that 4 pen 120. So 120 will be the correct answer. So 8 by 240 is equal to X, 4 pen by X. So this is equal to 120 rupees. So 4 pen will cost 120 rupees. If 5 books cost 500 rupees, how much do 15 books cost? So 1 book cost is equal to 500 by 5 is equal to 100. So 15 book cost is equal to 1500. 5 books by 500, 15 books by x is equal to 1500. So 15 books cost 1500. So let's see problem number 9. So if A and B together can actually complete a task in 8 days. Okay, so what do A and B do? So they complete a task in 8 days. Okay, so combined work rate is equal to 1 by 8. Okay, so while A alone can complete the same task in 12 days, so A work rate is equal to 1 by 12, right? So it asks us that how many days will A alone take to complete the task. We all know that combined work rate formula is 1 by x plus 1 by y, right? That is actually equal to 1 by 8, right? So this implies that this is equal to 1 by x, right? So we have an unknown here, that is 1 by y. 1 by y is equal to 1 by 8 minus 1 by 12. That is equal to, so this will be 24. 3 minus 2 is equal to 1 by 24. Okay, so this implies that y is equal to 24. So y is the amount of time that we will take to complete the task. So it will be 24 days. Okay, so this can be only solved by this traditional method. Okay, calculating the work rate and then using the equations to solve it algebraically and arrive at the conclusion. So let's go forward and see the step-by-step solution. So find the combined work done by A and B in 1 day and the work done by A in 1 day. So combined work done by A and B is equal to 1 by 8 of the job in 1 day, right? So work done by A is equal to 1 by 12th of the job in 1 day. So calculating the work done by B in 1 day. So work done by B is equal to 1 by 8 minus 1 by 12, that is equal to 1 by 24 of the job in 1 day. Okay, so find the number of days required for B to complete the task alone. So it is the reciprocal of work done by B. So 1 by work done by B will be number of days. That is nothing but 24 days to complete that task alone. So let's see the problem number 10. Okay, so the price of a book is actually increased by 25%. Okay, if let price of book is equal to X. So this implies that new price is equal to X plus 0.25 X. So 0.25 was multiplied here with X. Multiplied with X because it is decimal form of 25%. Okay, because 25% is equal to what? 25 by 100, right? So this is nothing but 0.25. So that is why we have multiplied here, because it has been increased by 25%. So the initial price remains and the increased price is 25% of X. So this is equal to nothing but 1.25x, right? So this is the new price. Okay. So by what percentage should the new price be reduced to bring it back to the original price? So this is the new price, right? So how much should we reduce? So 1.25x minus y is equal to 1x. So this implies that y is equal to what? Y is equal to 0.25x. So what we want to calculate is, we want to calculate the reduction percentage. So reduction percentage is equal to, so this will be the new 100%. Okay, so it will be 0.25x by 1.25x. So this will be 5 into 100, right? So this is equal to 20%. So the price must be decreased by 20% in order to get the original price, or get back to the original price after increasing it by 25%. So let's see the step-by-step solution. So let's assume the original price of the book be P units. Okay, so when the price is increased by 25%, the increase in price becomes 0.25p, because it is the decimal form of percentage, right? So the new price becomes p plus 0.25p, that is 1.25p. So let's say we need to reduce the new price by x% to bring it back to the original price. So x% will be what? 1.25p minus x by 100 into 1.25p. So we want this price to be equal to p. So this implies, if this is equal to p, so expanding further, what we can guarantee here is 1.25p minus 0.0125xp is equal to p. So this is equal to 0.25 by 0.0125 is nothing but x is equal to 20, right? So we have already arrived at the conclusion that you need to reduce the price by 20%. Okay. So here also you can see. So this is the correct answer. So the new price should be 25% reduced to bring it back to the original price after the hike in the price. Okay, the hike was 25%, but the reduction was 20%. Why? Because we considered the new price, that is the hike 25% hike price as the what base price, after which there should be a reduction. So the reduction must be 20%. So let's go forward to the next question. So problem number 11. A laptop is sold at a discount of 15%. Okay. So discount in the laptop is 15%. So original price, laptop price is equal to X. So this implies new price is equal to new laptop is equal to what? X minus 0.15x is equal to 0.85x. So this is the new laptop price. Okay. So then the discounted laptop is sold for 20% more than its discounted price. Okay. So what the shopkeeper does is he sells it at a 20% hike on the discounted price. So 20% of 0.85x. So this implies what? 20 by 100, right? Into 0.85x. So this implies that this is what? So 1 by 5, right? So 0.85x by 5. So this will be what? So 17 by 100 into x is equal to 0.17x. Okay. So this is the amount that is being hiked on this price. So adding these two, so 0.85x plus 0.17x. So what we are arriving at is what? 102x. So 1.02x is the new price of that laptop. So the overall profit percentage will be what? So overall the profit is 0.02x and the original price was 1x into 100, right? So this will be what? 2 by 100 into 100. So it will be 2%. So the overall profit is 2%. Okay, so let's assume the original price of the laptop be P. So when the laptop is sold at a 15% discount, so the decrease in price becomes 0.15p. So the discounted price becomes what? P minus 0.15p is equal to 0.85p. So now the discounted laptop is sold at 20% more than its discounted price. So the increase in the discounted price is 0.20 times. So 0.85p is equal to, so 0.2 into 0. So it is 0.2 into 0.85p is equal to 0.17p. Okay. So the price at which it is sold after this increase is 0.85p plus 0.17p is equal to 1.02p. Okay. So the net profit is 0.02p, right? So the profit change is equal to difference in price by original price into 100. So this much into 100 is equal to 2%. So the value is positive. So it indicates what? Profit, because the selling price is greater than the original price or the cost price. So the net overall profit is 2%. Okay. So let's see problem number 12. So the price of a car is actually increased by 10% and its value decreases by 20% annually. So find the effective percentage change in the value of the car after 2 years. Okay. After 2 years, how much value will the car hold? Okay. So the price of the car has been increased by 10%. Okay. So let value of car is equal to x. So new price is equal to 1.1x, that is equal to 1x plus 0.1x, that is being a 10% hike. Okay. So the value decreases 20% annually. Okay. So this is the hike price at which a customer buys. So he bought it at 1.1x rupees, right? So after 1 year, what happens is its value decreases by 20%. Okay. So 20% of 1.1. 1.1 into 0.2. Okay. So initial price increase is equal to, let's assume the original price to be P unit. So the increased price is 1.10 P after hike. So the annual depreciation for the first year will be 20%. So 20% of 1.10 P is equal to 0.22 P. So the value of the car after the first year becomes 0.88 P. So if the customer wants to sell the car, he will be getting this much back. So annual depreciation for the second year will be what? 20%. Okay, so 20% of the first year's ending value. So this much value is 20%. This much into 0.88 P, so is equal to what? 0.176 paisa or P unit. So the price of the car after the second year becomes 0.88 P minus 0.176 P. That is actually equal to 0.704 P. Okay. So calculating the effective percentage will be what? So the original price of the car is P. So the value of the car after 2 years is 0.704 P. Net loss is 0.704 P minus P is equal to minus 0.296 P. Okay, so this much amount of loss he will be bearing after 2 years. Okay, because the price at which he can sell now is 0.704 P. So effective percentage change is equal to change in value by original price into 100. So change in value by original price is equal to P into 100 is equal to 29.6. So this much value have been depreciated. Okay, so the effective percentage in the value of the car after 2 years is 29.6. So this is the correct answer. So problem number 13. If 10 workers can complete a project in 12 days, how long will it take 6 workers to complete the same project? So what we can do here is we can use the work time equation. Okay, number of tasks is equal to 1. So it is number of tasks into number of worker into number of time or amount of time, that is 12. So what we have is number of tasks, that is 1, and 6 worker, right? So number of worker is equal to 6. So number of days that we don't know. So let it be X. So this implies that X is equal to 10 into 12 by 6 is equal to, so this will be 20. So 20 will be the final answer. That is 20 days will it take for 6 workers to actually complete the same project, right? So calculate the work done by 1 worker in 1 day. So 1 worker's work rate is equal to 1 project by 10 workers into 12 days, right? So this is equal to what? Time is equal to 1 project by 6 worker into work rate. So this is done by the method 1, that is the traditional method, okay, using the work rate formula. So it will take 6 workers to approximately 20 days to complete the same project. Okay, so that's all for now. Thank you.